collision theory of chemical reaction. Okay. Well, collision theory, it has been introduced by scientists Max Ross and William Lewis in 1916 to 18. Okay, where they have given insights. Okay, insights into energetic and mechanistic aspects. Mechanistic aspects of chemical reactions. All right, there they have given that rate, it is equals to K product of this Arrhenius equation. All right, in collision theory. Let us discuss this in detail. This theory, it is based on the kinetic theory of gases, all right, where the reaction, it is initiated by the collision of hard molecules, all right, say the reactants. All right, the collision frequency, it is determined by Z. What is collision frequency? That number of collisions that are taking place per second per volume of a reaction mixture. Let us understand this by example. So this is a bimolecular elementary reaction, okay, where A and B are the reactants and they are forming some product. How we are going to write the rate of reaction for this? The rate will be the collision frequency of these two molecules, okay, that will be the rate constant. That will be the K, okay, as I have just discussed. All right, here what ZAB, this is the collision frequency of the reactants, and this is the fraction of molecules with the energies that are equal to or greater than this activation, that is EA, this activation energy, where A, it is the Arrhenius factor, or say frequency factor, and R is the gas constant. EA, it is given as the activation energy, and it can be measured in joule per mole. Okay, the reaction is applicable to simple atomic species or molecules and not for complex molecules. Let us discuss how these what are these effective collisions. The collisions of molecules which are having proper orientation. Now there are two conditions required for effective collisions of molecules. First thing, they require a proper orientation. Okay, why require proper orientation? If there is no proper orientation, the molecules, they will bounce back. Okay, and other condition is what? For proper effective collision of molecules, we require a sufficient amount of energy, which is also called threshold energy, which will facilitate the breaking of bonds between the reactant and form a new product. Or for example, if you see the reaction here, in the reactant side, we are having this CH3Br with OH. Okay, if the reactants, they are improperly oriented, then no products will form. Okay, the reaction, it will bounce back. All right, and here we are having proper orientation, where there will be an intermediate form in the reaction, and we can get a proper product, all right, with sufficient amount of energy. So this is a reaction of methanol. This is the production of methanol from this bromoethane, okay, which depends on the proper orientation of reactants for effective collisions. Okay, next is some point related to the concept of probability, which is also termed as P. Then the proper orientation of reactants. It included the rate of effective collision, which is represented by P, or say probability factor. That means it can be represented as like this in the equation, where P is what? A probability, or say steric factor. What is the drawback of this collision theory? That it ignores the natural aspects of matter. All right.